Okay, let's start. So today we are going to speak about the electric flux and introduction and explanation of the Gauss law. So last lesson we had problem. We solved problem about the electric field, right? And we solved the electric field lines. So electric field lines will be like this, right? So this one is the electric field lines. Electric field lines. So what about the electric flux? What about the electric flux? So electric flux is the rate of the flow of the electric field through a given surface. If we have such kind of the electric field lines, so we need to find here the electric flux, okay? F. So this one, the electric flux. Electric flux. How should we know here? So we have such kind of surface here, like this. And we take here this small area. This is equal to dA. And we have here the electric field, okay, E. And then here this is some angle theta. So here we have the piece of the electric flux, let's say delta EF is equal to E multiplied by this area dA multiplied by cosine of theta. This is a small piece of the flux, okay, here. And now we have the total flux. Now we should find here total flux. How? If we take the integral both, and we got here the total flux or net flux. The total flux is equal to integral of the E multiplied by dA. So this one is equal to what? So E vector multiplied by dA vector is equal to E multiplied by A multiplied cosine of theta. So the total flux is equal to integral of E multiplied by A cosine of theta. This is the flux. Okay? And the unit of flux is what? So unit of flux is, so this one is electric field, right? So unit of electric field is what? Okay, so this A is area. So the unit of the area is meter squared. So the unit of the electric flux is E multiplied by A. So E is Newton multiplied meter squared divided by Coulomb. This is the unit of the electric flux. So to better understand the electric flux, we have three pictures here. First one, which is the angle is 0 here, right? It means that here the maximum flux. And here some angle, which is theta, is here 60 degrees. And the last one here, the angle is 90 degrees. This means that the cosine 90 is equal to 0. Okay? So, for example, we have example number 1. We have the electric field lines which going to from left to right, and this is equal to, let's say, 2 multiplied 10 to the 3 newtons per coulomb. And we have the surface, rectangular surface. Rectangular surface A, let's say 2 meters square. This is the area of the rectangle. Okay? And this an angle between the two, angle between the air's surface and the electric field is equal to theta, let's say 45 degrees. And we should find here the net electric flux. How? So F net is equal to dA multiplied by cosine of theta, right? So E is equal to 2 multiplied 10 to the 3 multiplied 2 meters square, and cosine of 45 degree is equal to what?
Square root of 2.
Square root of 2 divided by 2. So yes.
Square root of 2 divided by 2.
Yes.
So that's the association between the other.
So the here the 4 multiplied 10 to 3 square root of 2 divided by 2. How much is it? So square root of 2 is equal to the approximately 1.4. Okay, so 4 multiplied by over 2 is 2. 2 multiplied by 1.4 is 2.8. So 2.8 multiplied 10 to 3 Newton meter square per coulomb. If the angle is here, the not 35 degrees is equal to 90 degrees, then the flux is equal to 0 here. If the angle is 90 degrees here, it means that the cosine 90 degrees is equal to 0, so the flux is also equal to 0. Okay. What about the Gauss law? Gauss law says that may I clean this part? Okay. So, what about the Gauss law? Gauss law. Any closed surface, so let's say sphere, we have such kind of sphere, okay? And it has the positive charge, let's say Q0, and its radius is equal to VR. So Q is inside of the sphere, okay? Q. What about the total flux? Total flux of sphere. So total flux of the sphere is equal to the sum of the charge divided by the permittivity of the free space, okay? And this is the Gauss law. So the flux does not depend on radius of the surface of the sphere, of the surface sphere. So how should we know that equation? How should we calculate this one? Okay, the flux is equal to A, E multiplied by A, right? And the E is equal to K multiplied by Q divided by R squared, right? What about the A of the sphere? A, total A, area. Yes, area is 4 pi R squared, right? If we put the 4 pi R squared instead of A, 4 pi R squared. And the K is equal to 1 divided by 4 pi epsilon 0, right? This is K. So we should put the instead of K 1 over 4 pi epsilon 0. So 1 divided by 4 pi epsilon 0 multiplied by Q divided by R squared multiplied by 4 pi R squared. So we should remove 4 pi R squared. Here 4 pi, here also 4 pi R squared. We have only Q divided by epsilon 0. This is okay. It means that any closed surface any closed surface, the flux is equal to sum of the Q divided by epsilon 0. Okay? This is the Gauss law. For example, let's say we have this is the example number 2, okay? Example number 2. We have the surface, sphere, which is closed surface, okay? And here is the charge, the positive charge Q is equal to, let's say, 25 nanocoulomb, and the radius of the sphere is equal to, let's say, 2 centimeters. What about the total flux of the surface? Can you calculate?
Epsilon 0 is equal to 1.
Sorry?
Epsilon 0 is equal to 1.
No. Epsilon 0 is permittivity is equal to 8.85 multiplied 10 to the minus 12. So the F is equal to E multiplied by A. So A is equal to 1 over 4 pi epsilon 0 multiplied by Q R squared multiplied 4 pi R squared. 4 pi R squared are cancelled, so we have the Q divided by epsilon 0. Q is equal to 25 nanocoulomb. Nano means multiply 10 to the minus 9 divided by epsilon 0. Epsilon 0 is equal to 8.85 multiply 10 to the negative 12. Okay? So 25 divided by 8.85.
2.8.
2.8. So 2.8 multiply 10 to the 3 Newton multiply meter square per coulomb. Okay, understand? Now we will solve the problem, the exam simulation, okay? So exercise is number 1. Solve the problems. You have two charges, which is Q1 and Q2. Q1 is equal to 10 microcoulomb, Q2 is equal to 20 microcoulomb. They both positive. You must find the force between the two charges. First of all, you should find this position of the two charges, okay? The position of the first charge is equal to what? 2 plus, sorry. So this is the 1, 2, 3, 4. Here 4 and here 3. 4 and 3. Okay? Here 1, 2, 3, 4, 5, 6. 6, 3, 2, 4. Okay? So the position of the first charge is equal to 2 plus 4j. Okay? 2 plus 4j. And the position of the second charge is equal to 6 plus 3j. Exercise number 1. This is the real part. This is imaginary part. Okay, so the first charge is here, Q1, which is positive. Here is 4. Here is 2. Next charge is here, Q2, here 3, and here 6. So Q1 is equal to 10 microcoulomb. It means what? 10 to the minus 5 coulomb, right? Q2 is 20 microcoulomb. 2 multiplied 10 to the minus 5 coulomb. This distance is meter, so R1 is equal to 2 plus 4j. R2 is equal to 6 plus 3j. So first of all, we should find the distance between the two charges, these ones, okay? So distance R12 is equal R2 minus R1. So 6 plus 3j minus 2 plus 4j is equal 4 minus j. Just minus j. Or minus 1j. So force between the two charges, we should use the Coulomb laws. F12 in vector form is equal to what? K multiply Q1, Q2 divided by R squared. R12 squared. So this one means that you unit vector, right? And this is equal to what?
Absolute value.
No. No. This one equal to R12 vector divided by absolute value of R1 and 2, okay? So this one is equal to R2 minus R1. So this is equal to 4 minus J divided by, this one is the absolute value of this vector, okay? It means that the square root of 4 squared plus 1 squared. Okay, so 4 minus J divided by square root of 17. Okay, how much is it? The square root of 17?
4.1.
4.1. Okay, so 4 over 4.1 minus 1 over 4.1 J. How much is it? I think it's 0.97. Right? 4 over 4.1. How much is it? 0.97.
Yes.
0.97 minus 1 over 4.1.
0.24.
0.24 J. Okay? So F1 and 2 is equal to K is equal to 9 multiplied 10 to the 9 multiplied Q1 10 to the negative 5 multiplied 2 multiplied 10 to the negative 5 divided by R squared. R squared. This distance squared, okay? This one. So here is equal to 1, here is equal to 4. So this one is R, okay? R squared is 17 multiplied by 0.97 minus 0.24 J.
17.
Yes, R squared. Here 4, here 1. 1 plus 16 is 17, okay? Here is the square of the R here.
Okay. Koydum solda. Square root.
Here not square root.
No.
Square of the R here, it means 17 here, okay? So, the 2 multiplied 10 to the negative 10 divided by 17 multiplied 0.97 minus 0.24 J. Can you calculate 4 divided by 17? Not 4, I'm sorry, not 9 multiplied by 2 here.
1.8.
18. 9 by 2, 18, and here the
Yes.
here just negative minus 1, or just 1.8 here. Now it's okay. Okay, how much is it?
0.103 minus 0.025.
Yes. 0.097 minus 0.024 J, right? Seems like this. The unit of this one is newton. .8 divided by 17 is the approximately 0.1. So the 0.1 multiplied by 0.97 is equal to 0.097 minus 0.024 J. And the next exercise, exercise number 2. They bore microcoulomb. Here is 2, here 4. 1, 2, 3, 4, 5, 6, 2.
Four and 6 2.
Yes. Here only scalar form, not vector form. It's more easy. So Q1 15 microcoulomb, Q2 40 microcoulomb. Position of the Q1 is 1 is equal to 2 plus 4J. Position of Q2 is R2 is equal 6 plus 2J. So distance between the two charges and not J.
Yes.
Because this is the scalar form. So we should find just the distance between the two charges. Okay, here 4, there is 2. So R square is equal to 4 square plus 2 square, 16 plus 4, 20. So F is equal to K multiplied Q1, Q2 divided by R square. So K is equal to 9 multiplied 10 to the 9 multiplied 15 multiplied 40 10 to the negative 12 divided by R square is 20 meter. Okay, so 0.27. Understand?
Yes.
Okay, next one. Superposition of the bond dilation.
We should find F total.
F net force Q0 here. We have only real part, right?
Yes.
So, exercise number 3. It means that here the initial point is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. 12 and 6, here 0. So, this is the first charge, which is negative. Q1, Q2, Q0. Q1 is negative. Negative 10 nanocoulomb. Q2 is positive 10 nanocoulomb. Q0 also positive 20 nanocoulomb. So here is 0, here is 6, and this is the real part. So we should find the here total net force on position Q0. Okay. So F net force is equal to what? F10 vector plus F20 vector. Okay. F10 is the force between the Q1 and Q0. F20 is the force between the Q2 and Q0. Okay. So F10 is equal to what? K multiply Q1 multiply Q0 divided by here the, let's say this is the position R0, this is position R1. So R10 is R0 minus R1. 12 plus 0J minus 0 plus 0J. Okay, this is the just 12 plus 0J. Divided by R10 squared multiply R10 unit vector. Okay, and this one is equal to 1 because we have only 1D. This one is equal to 1. What about the F20 vector? K multiply Q2, Q0 divided by R20 square, R20 vector. So R20 vector is equal to, vector R20 is R0 minus R2. So this is the 12 plus 0j minus here the 6 plus 0j is equal 6 plus 0j. Defined? How much is it?
I have one question because this. We have an F20, for example, is 6 in square. It will be 6 because 6 squared plus 0 squared in the square root. Yes? Or is it will be 36?
You mean here the
I mean that per squared of 20, for example, will be square root of 6 squared plus 0 squared, or it will be 36.
it means that the extent will value, okay?
Yes, yes.
You can use the find the unit of the F20, you can use in this form. But here you can find of the distance square. It means that here is the 6, right?
Yes.
Square. Okay. I have understood. You can use this form only to find the unit vector of the this. So R20 unit is equal to R0 minus R2 divided by absolute value of R0 minus R2. Okay? So here you should put the 6 plus 0j, and here square root of 6 squared plus 0 squared. So 6 plus 0j divided by 6. It is 1 plus 0j, just 1. But here you should put the distance square. Distance square
Well,
means that here 12 squared here,
and
it means 144, and here the divided by 36.
3.75.
No problem. F1 and 0 should be negative, okay? Because here the negative charge. Here. But F2 0 is positive. After that, you should subtract from F2 0 to F1 0.
37.5
Newton's point. Perfect. Okay, next one. We have the charge, which is the 20 uncoulomb here, and you should find electric field on point P. First of all, you should find distance from charge to P. Okay, so 1, 2, 3, 4, 5, 6. Here 1, 2, 6, 2, and here 36 plus 4 is 40, square root of 40. And you should find the electric field at the point P.
on P on the 5
No,
and 2.
I think here, 4. 1, 2, 3, 4, 5, right, 5. So, and this is only the polar form, not the vector form. If you want, you can find the vector form. It's not hard to understand. This was equal to negative 12.5 and is negative 9 Newton. This one 15 and is negative 9 Newtons. F net force is 15 negative 9 minus 12.5 is minus 9. 37.5 Newton. You will switch off now. It's not working. Charger is not working now. Other.